If you've been seeing all the posts about Apple Sharp that lets you quickly turn any 2D image into essentially a 3D photo and want to start creating with it quickly and for free, this video is for you. To get started, we're going to head to anaconda.org to download Miniconda here. And we're going to click in the top right corner and hit Miniconda for Apple Silicon. And so once it's done, we're going to double click to run the installation wizard, which shouldn't take too long. Then we're just going to hit continue, continue again, continue one more time, and then agree. And then we're going to install it directly onto the computer. And this part of actually running the package scripts might take a little bit longer for you depending on your device. But once it finishes, we are then going to just quickly close it and move on to the next step. So to do that, we're going to go to the ML Sharp GitHub repo. I also will have the link in the description. And we are actually going to scroll down a little bit to the Getting Started tab just below. And we're going to actually copy this first part here where it starts with conda create, and we're going to go to a terminal window actually, and we're going to just very simply copy and paste that directly into the terminal and hit enter. And we can see here, it's going to just go and download all these things. We need to hit Y to hit yes, and it's going to download everything for us. And now that we have the Conda environment, we can go ahead and highlight Conda Activate Sharp. At the next terminal prompt, we can go paste that in. You can see actually right here, instead of base, now it says sharp. And so for this next step, actually, we're going to return to the GitHub repo, and we're actually going to scroll up to the top of the repo, and we're going to click on this drop down bar right here where it says code, and we're going to highlight under HTTPS the full domain that ends in .git. And so once we have that copied, we're going to return back to our terminal, and we're going to type in git clone, and then we're going to paste that link and then hit enter again, and it's going to actually clone the repository onto our computer for us. And it should only take a second. So now that it is done, we're actually going to go to our Finder, and we're going to find the folder of which it is enclosed in. You can actually see it in your path right here. So for me, it's just in my users folder. We're going to create two new folders here. We're going to create a input folder. And then secondly, we're also going to create an output folder, which we'll get to as to why we're doing that in just a couple minutes. So once we've gone ahead and done that, we're going to return to the terminal window and type in cd-ml-sharp, which is the name of the repository. And we can move to the next step, which is pip install-r requirements.txt. And once we copy that, we can just return to the terminal and now copy and paste that as well. This one may take a minute or so for you to download, so just be a little patient as it actually downloads. Okay, cool. So it finished downloading. So we're going to go to the next step, which is to test actually how the installation went. So we're going to grab the sharp -- help and just copy and paste that directly into terminal as well. And this might hang for like 30 seconds or so before anything happens, but that's totally okay. Don't worry about it if your screen freezes for a little bit. And we can see here, we know that it's correct, where we can see that both predict and render as well are there. So we can actually move on to the very next step, which is to actually go and run the prediction model. And so we're going to copy this here, and then we're going to return back to our terminal. We have the code, but what we need to do is we actually need to tell the computer both where to pull the input images from and then where to actually place the outputted Gaussian Splatting PLY. So for me, I actually went ahead and I put a downloaded photo of a cat in the input folder that we created just a minute ago. And we can see here it is the 3542.webp, and we're actually going to place that path within the code. So I'm going to go ahead and right click under the folder structure here and click copy input as path name, and that's actually going to let me just paste it directly into the command line. So I'm going to delete the path up to here and then just hit paste, and I'm just going to remove these quotes as well for me on both ends of it. And then the last thing that I need to do actually is put the name of the image itself. So in this case, it is 3542.webp, and yes, it does matter if you include the file type. So I do have to write WebP. If you're using JPEG, you have to use that as well. But now that we have that there, we can actually go ahead and update the output path as well. And just like we did before, we're going to copy and paste the path into the terminal. So we're ready to hit enter here. And I realized when I was recording this, I did make a mistake. So I opened up a new tab, which is why it looks a little different here, but it's the exact same line of code. And once we have this, we can go ahead and hit enter. And we can see here, it's going to start to actually download the entire model, which is about 2.5 gigabytes. So depending on your internet connection, it will take either a shorter or longer length of time, but this is only going to run on the very first time that we are installing this. And every time thereafter, it's going to be super fast, where the actual inference will only take about 10 seconds or so. Great. So we can see now that the Gaussian Splatting PLY has been outputted to the output folder that we specified. And we actually added a /Gaussians folder here, but we can see here's the PLY, and I double double click on it, we can see you can't really tell what is actually being contained in here, but luckily there is a completely free and open source platform called SuperSplat that we are going to drop this PLY into. And so you can see here, I just simply drag and drop onto the screen, and then I'm going to just move the camera slightly, and then I'm also going to remove these grid lines as well, and then turn off the highlighted splats, and you can now see we have ourselves a 3D photo. And so yeah, this is just a super quick and easy way to actually go ahead and get set up with this. We can go around, we can move around. We're going to fly around actually in SuperSplat using the arrow keys as opposed to the WASD, but it's super easy to navigate this, and you can save it, you can publish to the internet. It's a lot of things you can do from SuperSplat. So if we want to repeat this process, all we need to do is continue to add more images into our input folder, which actually I've already gone ahead and done. So we can see here, we now click on the input folder and we have several more options that we can go and process. And if we want to run it yet again, the only thing that we need to really modify is the actual input image name. And when you're in the terminal window, you just need to hit the up arrow to get the previous prompt, and we can see here it pops up right here. We're just going to scroll over to where we have the input image, and we're going to change the name to 4.jpg. Again, you have to specify the file type, and then we can literally just hit enter, and it's going to take roughly about 10 seconds or so to run it. It's super fast, and it's going to drop it also into that same output Gaussians folder, but with the name of the JPEG. And yet again, I can go to SuperSplat and drop it in, and we can see here is yet another 3D photograph. And in case you were wondering, it does actually work with black and white images as well. I also prepared quite a lot of other examples too from different photographs to showcase how it can work. This is an example I particularly like, of a bunch of sailors with swans. You get a nice overview of the depth in the actual image. You can really play around with this scene, and if you go to SuperSplat as well, you can actually go into the color settings menu, which is right here, and you can change around the transparency values or the black point and white point as well. You can make some really crazy effects from just a single 2D image. So here's just a fun little setting that you can play around with, but I'm going to hit reset, and we can just go explore a couple more images here. If you want to try out with landscapes, landscapes work as well. Pretty much any image that you throw at it, by and large, should give you something, unless you just have no depth at all in the screen. But overall, yeah, so this was really meant to serve as a high level and quick overview as to how to get started with Apple's Sharp for totally free. And so to run Apple's Sharp, again, you don't need to have CUDA or any specific device. You can really process this on a lot of different devices, and you can do it super quickly and completely for free too. So if anyone tries to charge you money for this, there's really no need to pay for this service. So if you stayed for this long, I really appreciate you supporting the channel, and please consider subscribing to the channel for more lifelike 3D videos surrounding the world of Gaussian splatting and other Radiance field representations. So thank you so much, and I'll see you in the next one.